This is an ADA extinction simulation. At 1:48 and 52 seconds Greenwich Mean Time, video broadcasts from the International Space Station shows a 22-meter diameter asteroid striking the Aikata nuclear power plant in southern Japan. Coordinates for the point of impact are 33 degrees 29 minutes north by 132 degrees 18 minutes east. The impact occurred at a 94-degree angle with the surface and, as a result, the asteroid's entire 500 kilotons of kinetic energy, equivalent to 30 atomic bombs, was transferred directly into the 3 nuclear reactors at that location. Because the asteroid was smaller than the 140-meter lower limit agreed to by NASA and the United States Congress, there are no systems in place to defend Earth from this impact. As a result, the members of the ISS could do nothing but watch, record, and report on what they observed. It appears that all of the reactor structures and fuel storage at that location were atomized and ejected into the upper atmosphere by the force of the blast. The Asteroid Defense Association's projection is that prevailing winds will drive that debris cloud to the east of Ground Zero, with the expectation that a cloud with lethal levels of contamination will make landfall in North America within 3 to 6 days, depending on weather conditions. It is possible that the resulting lethal cloud from this impact will continue eastward after making landfall and ultimately will circumnavigate the globe. Accordingly, all ADA members worldwide should activate their locator pins and proceed immediately to the closest ADA processing station for assistance. All non-ADA members should proceed immediately to the closest radiation fallout shelter in their area and wait for further instructions. Communications staff from ADA will stay on the air for as long as possible, and any additional information regarding this event will be broadcast on all emergency radio bands as soon as it becomes available. That concludes ADA simulation. We would like to thank you for your patience and wish those of you who are leaving us now a good day. For those of you who have elected to remain a little longer, we will provide a short briefing about key elements of the simulation you have just seen. The most likely result of the events depicted in the simulation that you just watched is the extinction of the human race by radiation poisoning and starvation. The obvious question then becomes, what are the chances that the events depicted in that simulation will occur? The Asteroid Defense Association believes that the best way to answer that question is to provide you with the facts behind that simulation so that you can answer that question for yourselves. First, the asteroid used in the ADA simulation is identical to the asteroid that ended in an airburst 30 kilometers above the city of Chelyabinsk, Russia in 2013. The only difference between the two asteroids was that the approach angle used in the ADA simulation was steeper, so the asteroid would reach the surface. Dashcam videos of the Chelyabinsk impact are running on the screen right now. Next, we'll address the odds of asteroid impacts. The best source of information related to asteroid impacts that ADA has located is a video produced by the B612 Foundation. That video was developed to build general public awareness of the asteroid threat that the public faces every year. A portion of the video follows for your reference.
The Nuclear Test Ban Treaty Organization monitors the Earth around the clock, listening for the infrasound signature of nuclear detonations. Between 2000 and 2013, this network detected dozens of massive explosions in our atmosphere. But not a single one of them was caused by a nuclear weapon. The actual cause? Asteroid impacts. Between 2000 and 2013, there were 26 recorded asteroid impacts on Earth, ranging in energy from 1 to 600 kilotons.
Moving on to Ground Zero, the Aikata nuclear power plant that was used as the Ground Zero source of nuclear discharge in the ADA simulation, is a well-run facility in southern Japan. It was selected for a number of reasons, but the most important of those is that it demonstrates that a small asteroid impact anywhere in the world can cause global extinction. Another unique reason for its selection is that it allowed ADA to use the verified plume data from the Fukushima Daiichi nuclear disaster to project the global spread of nuclear contamination. It also shares most of its operating protocols with the 450-plus commercial nuclear power plants, located in over 50 countries worldwide. In addition to those 450-plus nuclear power plant sites, there are more than 1,000 nuclear waste treatment, storage and disposal facilities around the globe. Those sites vary from well-managed facilities like the one in Tomioka, Japan, to those that engage in illegal transport, storage, and disposal of nuclear waste in countries where bribes can take the place of honest oversight. Unfortunately, for our purposes, any site that is not hardened against a nuclear blast will have the same result of spewing all of its nuclear waste into the atmosphere. In addition to the threat of experiencing extinction by the world's largest dirty bomb, mankind is also at risk from small asteroid impacts on storage facilities and laboratories containing weaponized bioagents, chemical agents, and pathogens. While these are not as long-lasting or potentially as far-reaching as vaporized nuclear materials, an asteroid impact on such facilities would result in a significant number of horrible deaths beyond its direct impact zone. And it will likely produce local contamination and area extinctions with unknown long-term consequences. What is even more troubling is that unlike legitimate nuclear facilities, some of these bioagents and pathogens can be produced in significant quantities in very small laboratories with limited equipment and raw materials. That potentially places them in the hands of rogue nations and terrorist groups at hidden locations. The only way to avoid extinction by impacts from this class of asteroids is to implement an asteroid defense system that can deliver the protection needed. But as the scientists, engineers and astronauts that formed the B612 Foundation have discovered, in 2002, NASA and the United States Congress agreed that the funding for such a system is not required. The reality is that the funding for NASA's asteroid deflection program limits that program to defending Earth against asteroids that are larger than 140 meters in diameter. And, unfortunately, the program cannot effectively defend against smaller asteroids that appear on short notice like the one that exploded in an airburst over Chelyabinsk. To provide you with the frame of reference, the illustration on the screen right now shows the size relationship of the Chelyabinsk asteroid to buildings in downtown London. The second asteroid shown illustrates the lower size limit for the defense system planned for by NASA and the European Space Agency. As a result, humanity's exposure to extinction is currently significantly higher than it would be with a full-range asteroid defense system in place. That concludes the summary of the facts that ADA committed to provide in this portion of its briefing. Also, for your information, ADA is currently developing a follow-on briefing to share additional information and present an outline of a possible solution for the current asteroid defense shortfall. If you wish to be notified of when and how that ADA follow-on briefing will be released, simply send an email to ada@asteroiddefense.org with the word "more" in the subject line and we will take it from there. Thank you for your time.